Hi, my name is William T. Dongo again. I'm here to give you a lecture about climate control and refrigeration technology. That is, the title is residential and commercial heating. And the lesson will be lesson number 2, in which we'll be talking about the furnace design. In this lesson, we'll be talking about natural convection furnaces, the different type, and then we discuss about the upflow furnaces, the different components of it, and then we gotta be talking about counterflow furnace, horizontal furnace, and then the gas pack furnace. Okay, the first one I'll be talking about will be about the natural convection furnace. Okay, we got the wall furnace. Wall furnace are normally found in older homes, apartments, or residential building addition. And then this is very simple in design. And the next one here we'll be talking about is the cabinet components. Cabinet components is a face panel. It is a face panel, decorative covers with louvers or vent to allow cooler air to enter the bottom and warmer air to exit at the top. Element shield. You got element shields used to lower temperature of bottom 1/3 of cabinet, and then primarily for children. And then heating elements that's combustion chambers where conduction heat transfer take place, separated combustion by products from surrounding air. And then you have the shields. The shields protects walls and stud from extreme temperature of the combustion chamber. That is 1,500 degrees to 1,700 degrees. And then you have a deflector inside that equipment. It slows down heat rise midway through the cabinet. And then you have a drop hood deflector. Drop hood deflector stops extreme temperature flow from burning top of each panel. And then you have a drop hood. Drop hood assure the removal of the product of combustion. In case if no draft, backdraft or flush pipe stop beyond the drop diverter. And then prevent a block flue or downdraft from affecting the flame. Drawn in air to dilute the combustion gases, what we call dilution air. Okay. And then the headers. Then the other part of it is the headers is a top mounting bracket for furnace installation. Converts the square opening of the drop hood to an oval operating for the vent. And then you have the burner. The burner is a form steel, natural gas only. For steel, natural gas only. For cast iron, natural gas or LP gas. And then we have another type we call a dual wall furnace. Dual wall furnace says they have 2 elements, 2 burners, double the capacity, always installed on an inside wall. And then you got another one furnace, you got direct vent wall furnace. No vertical vent needed. Used in multiple story building. Always on outside wall. Always on outside wall. And then the forced convection wall furnace. Forced convection wall furnace. Furnaces. Additional components for this. We have the motor. We have a vibration mounts. Motor support. You got fan blades. You got fan shroud. You got transformer 115 volts to 24 volts. Limit switch. You got a fan switch. Selector switches. And then side air package. And then you have the floor furnaces. Floor furnaces, okay, normally found in older home, apartment or residential building addition. Very simple design. Don't normally have remote thermostat capabilities. And then no forced convection floor furnace. And then we'll be talking about now the hot flow furnace. Hot flow furnaces is normally located in a basement or in first floor mechanical room. Fan is located below the heat changer. Return air enters at the bottom or lower sides of the unit. Heated air exit the top of the unit. Now we'll be talking about the hot flow furnace. Well, that's the hot flow furnace. Okay, hot flow furnace, just like I mentioned, heated air exit the top of the unit. One drawing I can show you, in which the only thing I can show you with the drawing is this one right here. This one right here. Usually this one is just like in my house. It's on the basement. Okay, you got the blower there that will blow the air up. Okay, go to the room, and then all the heating equipment are inside the compartment. Okay. And then we will continue the furnace components. The furnace components, you have the cabinet, 24 to 26 GA painted steel. 2 removable covers, normally blower cabinet cover, control and burner cover. Access holes for gas lines and electrical already in the cabinet. Some manufacturers have bottom plates that can be knocked out for return air access. Upper part of the cabinet that surrounds heat exchanger is insulated with foil back fiberglass insulation 1/2 to 1 inch thick. So you have an insulation there. And then 1 inch planks around supply air operating to attach the plenum. Okay, you got the plenum on top of these. And then we have a heat exchanger inside there. The heat exchanger is the part of the furnace where combustion of the fuel take place. That is heat exchanger, the part of the furnace where combustion of the fuel takes place. Usually made of 1 to 2 different metals. Stainless steel, that's 18 gauge, or cold rolled low carbon 16 gauge steel. Normally have welded seams. And then there are 3 types of heat exchangers. Individual section type. Number of separate heat exchanger. Each section has individual burner with the section joint together at the bottom so that a common pilot can light all burners. Each section is also joined together at the top so the flue gas can be directed to the common flue. Used only on gas burning equipment. And then we got the cylindrical type. Cylindrical type is a single combustion chamber. Use a single port fuel burning device. Use on gas, oil, coal burning equipment. Very inefficient. And then we got the secondary heat exchanger. Secondary heat exchanger used only on 99 plus efficiency gas furnace. Normally stainless steel. Water vapor from exhaust condenses into water. Technology is about 10 years old. Okay. Well, it's along, maybe 20 years old now. Okay. And then we have the other one now. We got the flue baffles. Flue baffles, metal plates located at the top of its heat exchangers opening. Restrict the flow to the combustion products. Restrict the flow of the combustion products. Increases efficiency. Better heat transfer must not be removed. Remember that. The flue bubbles must not be removed. Drop hood or diverter is a relief opening. Draws in dilution air on all natural draft gas furnaces. And then we have the blower assembly. The blower assembly is a metal housing with a centrifugal fan and a motor. A cut-off plate. Maybe separate plate attached by screws or maybe part of the housing itself. Prevent air recirculation. Improves the air pattern as it leaves the blower. Blower must never operate without cut-off plate installed. All blowers are either belt-driven or direct drive. Okay, belts can be belt-driven or direct drive. And then the one we're going to talk about is the gas manifold. Gas manifold is a pipe that distributes the gas to the burners. Provide a means for securing the burners. Older manifolds have threaded holes with a plug for checking manifold pressure. Okay? Proper alignment of the manifold and supporting brackets are critical for proper burner operation. Contains the burner orifice. Okay? Contains the burner orifice. The orifice is a hole in the spud. The burner orifice is factory size to meter the correct amount of gas to the burner. The gas flow rates depends on the size of the orifice and the gas pressure behind it. The gas flowing from the orifice is in the form of jet stream. And then you got the atmospheric burner. So we'll be right through here, atmospheric burner. Atmospheric burner, air shutter, used to adjusting primary air. Mixing tube, venturi, where gas and primary air are mixed. Atmospheric burner, continued, used on older furnaces with cylindrical type heat exchanger. Also known as single port or monoport burners. You got the half-chute, in-chute, single port burners requires 50% more primary air than slotted or ribbon burners. Flames have a tendency to lift. Flame have a tendency to lift. To manifest lifting, single port burners usually have a flame retention devices. Crimp ring inserted just inside the lip of the burner port. One of the most inexpensive burner to manufacture. And then we got a drill port burner. Drill port burners have a number of separate, relatively small circular ports. Cast iron or sheet metal, normally water heaters. And then we have the slotted port burner. The slotted port burner have a series of parallel slots across the top of the burner, normally made out of cast iron or stamped sheet metal. Have a tendency to create flashback. Economical to manufacture. The next one, we have a pilot burner. Pilot burner. Well, pilot burner continued. The pilot burner used to light main burners. Each time the thermostat calls for heat. An automated gas pilot consists of an automatically pilot device and pilot burner. The automatic pilot device either directly shut off the gas supply to the main burner or actually a gas shut off device when the pilot flame is extinguished. Okay, now extinguished. Now we'll be talking about the continuation of the pilot burner. The pilot burners has two functions. Provide the flames to light the main burner. Provide heat energy needed to operate the pilot safety devices. Primary aerated pilots have a small primary air operating in the tube. Primary air openings open plug with lint or dust. No primary aerated pilots. Developed to overcome service problem of pilot air opening blocked by dirt, dust, or lint. And then you got target type pilot. Target type pilot designed so that the gas jet mix with air in the open. Most common type used. Now we're gonna have a burner flashback. Burner flashback, inverted inner cone extend into the burner port and ignites the mixture inside the burner. The burning inside the throat is incomplete. Combustion resulting in the soot deposit. It is also dangerous because the heat produced by the burning inside the burner throat could damage the burner due to overheating the metal. And then causes of flashback. Flashback is more likely with flash burning gas, LPG. When primary air is increased, when a burner is very hot, when a burner is underrated. A leaking gas valve which lets a small amount of gas flow to the burner when it is off. And then we got extinction pop. Extinction pop. When blast back take place on extinction, may take place instantly or may be delayed several seconds. Normally, to eliminate extinction pop, decrease primarily is to burner. Okay, the next one we'll be talking about will be letter B, which we go here now is to the counterflow furnaces. So counterflow furnaces used in-house having an under the floor distribution system. The fan is located above the heat exchanger. The return and plenum is connected to the top of the fan area. And then warm air supply plenum is connected to the bottom of the enclosed cabinet. Okay? And then we have the horizontal furnace. Horizontal furnace used in attic spaces or crawl spaces when the height of the furnace must be kept at a minimum. Air enters at one end or of the unit through the fan and filter compartments and is forced horizontally over the heat exchanger extending to the opposite end. And then manufacturers are now making combustion counterflow horizontal furnace. They may be used for either application. And then you got the gas pack furnaces. Gas pack furnaces. Gas pack furnaces normally have both heating and air conditioning in one cabinet. Most commonly used on light commercial application. Contain same components as residence furnaces. Supply and return air opening are either end-shot or down-shot. End-shot gas pack. End-shot gas pack normally supply and return air opening are side by side on one end of the unit. Down-shot gas pack is normally supply and return air opening are side by side on bottom of the unit. Some gas pack are combination end shot or down shot. And then supply and return air opening are either end shot or down shot. All gas pack requires a roof curb. Roof curb is a metal frame used for supporting the gas pack. As supply and return air connection when used in downshot application. As roof flushing capabilities for leakage, roof curb must be level. Can be welded to steel beams or nailed to wooden beams. So that's completes the lecture in here. And to make the summary, the one we talk about today is the lesson 2. We got the furnace design. We talk about the natural convection furnaces. We talk about the wall furnaces, cabinet compartment, dual work compartment, direct vent heating, forced convection wall furnace, flow furnaces, and then you got the hot flow furnaces, and then you got counterflow furnaces, and horizontal furnaces, and then the gas pack furnaces. Okay, you might say, or you might see here that some of the old houses are still using this particular type of equipment, but since we got a lot of explosion in real estate, they're building different so many types of new houses. Some of this unit might not be used in there, but over here in my area in Dela City, we still use a lot of this type of equipment. So and then if you're really good at these heaters like this, you're gonna have a lot of business. If you become small business people, or small, have your own business in repair and construction of installing this type of equipment. So I'm thanking everybody about if you watch my video. This one is just for training and information purposes only, and not used for you to follow my lecture as your guide for designing the building. Or okay, I thank you again, and I see you again.